The question is, a wire is stretched 3 millimeter by a force of 150 Newton, assuming the elastic limit is not exceeded. That means, we have a graph like this. This is strain, and this shows stress, and the point of elastic limit is this one. This is the point of elastic limit. We know that from this up to this, these zones are considered to be the elastic zone, and this zone are considered to be the plastic zone. That's the difference. So if it exceeds, it cannot regain its original shape and size, but below this, it's possible to regain its original shape and size. So that's why it said, assuming the elastic limit is not exceeded, the force that will stretch the wire is 5 millimeter. Then for what we need is just to find the force that will stretch this much amount, but for this much amount it's 150 Newton. So we need to find the force that stretch the wire this much amount, this much value of change in length. But for this much value of change in length, we have got this one. So we proceed like this. We know that Young's modulus is equal to tensile stress over tensile strain, and this is equal to the force perpendicular divided by the area over change in length divided by the original length. So this is the formula. So to proceed with this, we need to find the change in length. Therefore, y is multiplying both sides by change in length over the original length, and finally we'll get a result, or if you want, the force. So y, which is Young's modulus, multiplied by the change in length over the original length, is equal to the perpendicular force divided by the area and y change in length over the original length multiplied by the area, which is equal to the force perpendicular. Force perpendicular, the area, change in length. We have the Young's modulus, the original length. Now exchange these two, and we will get this one. That means y multiplied by the area over the original length multiplied by change in length, which is equal to the perpendicular force. So we have this value y, which is equal to multiplied by the area, the original length. Change in length in the first case is 3 millimeter, which is equal to 150. So y, the area original length, is equal to, this is Newton, 150 Newton divided by 3 millimeter, and this is equal to 50 Newton per millimeter. So this is the value of y multiplied by the area over the original length, which is equal to 50 Newton per millimeter. Now we have got this result. Now let's apply this to the second case. That means y times the area over original length. Now this becomes 5 millimeter, and the force is not known, the perpendicular force. Y over original length is already known, which is 50 Newton per millimeter multiplied by 5 millimeter, and this is equal to the perpendicular force millimeter. This one multiplied with this, it becomes 25 Newton. A over the original length multiplied by 5 millimeter, which is equal to the force perpendicular and we already have the value of y over the original length, so which is equal to 5 Newton per millimeter. Multiply y with 5 millimeter cancel by millimeter 5 times this one is 250. This is the answer. The second question number 2, in the circular rod of cross-sectional area 100 millimeter square has a tensile force of this much, which is 100 kilonewton, or it is 10 raised to 5 Newton applied to it. So the stress in the rod is, so this is multiple choice, and it should be 1 megapascal or 1 kilopascal or 1 gigapascal or 100 megapascal. Okay. And the area is given as 100 millimeter square, so we need to change this into meter square. So to proceed, we know that 10 millimeter is equal to 1 centimeter, and 100 centimeter is equal to 1 meter. Therefore, 1 meter is equal to 1000 millimeter. This means that 1 meter square is equal to, this is 10 raised to 3, and it is meter square. 10 raised to 3 times 2 becomes 10 raised to 6 millimeter square. So the given value is 100 millimeter square. So the question is, if we have 100 millimeter square, what will be in meter square? So x will be equal to 10 raised to minus 4 meter square. X means area, therefore area is equal to 10 raised to minus 4 meter square. We know that stress is equal to the force divided by the area, the perpendicular force, and therefore the force is already known, which is 100 kilonewton divided by the area is minus 10 raised to 4 meter square. Therefore this is equal to, this is 100 and this is 6, so we have 10 raised to 6 kilonewton per meter square. This is kilo 10 raised to 3, 10 raised to 6 times 10 raised to 3 Newton per meter square. This is 10 raised to 9 Newton per meter square, so which is equal to 1 gigapascal. So the answer for the first question will be equal to the answer for the question is 1 gigapascal. It is 1 gigapascal because it is 1 GB, so sometimes the kilo will be forgotten, so you have to remember that this should be considered. Therefore Newton per meter square is only pascals, therefore this is the answer.